Hi and welcome to this next video from integration, and previously you'll have looked at the basic process of integration and how to deal with something called indefinite integrals, i.e. when you get that thing that's the constant of integration. But what we're going to do in this series is look at something called definite integrals and look at how they're used, what they're used for, and how we go about doing those. So we've got this idea of definite integrals between limits, and we're going to see how we can use integrals to find the area between curves and the x-axis, and also the area between two curves. So let's just kick off with this idea of what a definite integral is and how you deal with a definite integral. So here we go. So far we had integration has been the reverse of differentiation, but as you've guessed from the previous slide, there's a whole lot more to it than that. We use differentiation to find the value of the gradient at a particular point. That's essentially what differentiation does with regard to curves. Integrals have got applications to curves as well, and it's to do with areas under curves. But first of all, let's just look at what we actually mean by a definite integral. So here we have our definite integral, and what we've got is the integrate symbol as before. We're going to integrate that expression. We're going to do it with respect to x. And the new bits that we've got is we're going to integrate it between limits of 2 and 1. So that's the new part of it. Now, there's a whole load of notation that you need to get used to here, and you do need to be careful with your notation and make sure you're very clear, because this goes to the heart of your ability to communicate mathematically and make it clear as exactly what you're doing. So here we go. Let's do the integration as normal to begin with. So we're going to integrate x cubed, that's going to become x to the 4 over 4. 6x squared is going to become 6x cubed over 3, so 2x cubed, and then minus 4, add 1 to the power, this becomes minus 4x. So there we go. And the key thing to notice here is, first of all, we've now got, as I said in the video, here we've got our integrate symbol, as in we've got to do the integrating. Now we've done the integrating, I've put my integrated expression inside a big pair of square brackets, and now the 2 and the 1, my limits, are appearing after the brackets here. Okay? So it's very, very important that we're clear on the difference between this thing over here, which this is saying we've got to do some integrating between limits. Here we've done the integrating, and now what we're saying is we've got to apply these two limits here. And the way we're going to apply those limits is by substituting in the values. So we're going to put a 2 into here. So there you go, 2 to the power 4, 2 times 2 cubed, 4 times 2. So I'm just substituting 2 into this expression. And so I've put in, or substituted in the upper limit of 2. And now what I'm going to do is subtract the lower limit. So we're going to do a subtraction there. It's always a subtraction every single time. It will always be a subtract. And I'm going to put my lower limit in there. And now what we've just got is a numerical expression that we're going to figure out. Now, the reason why we're doing this is going to become much clearer when we start looking at areas and the curves. But for now, if you just go with it, go with the process, this is what we're doing. And so we're going to now evaluate that. So here we go. There's my first bracket, which is that one tidied up. There's my second bracket, tidied up. And there we've got our two expression, our two values. And notice you've got to be a little bit careful. Here we go. We've got a minus and a minus, which becomes a plus, which is 55 over 4. Now, I've gone through it in a lot of detail there, and I've done the whole thing numerically. But obviously you've got calculators. In the exam, you've just got to make sure that when you get something like this, the phrase that you see on mark schemes is substituting in the limits, which is this thing, and shows clear intention to subtract, which is that bit there. So making sure you show clearly that you're subtracting. But to be quite honest, they don't need to see all the working out, so you could just bang these numbers from this line here straight into your calculator, and it will spit out the answer for you. Okay, so that's how we go about doing it. Let's have a look at one that's a little bit more complex. And here we've got an integral, so we've got a root, we're going to have to deal with that, and we've got this squared thing. So what I'm going to do is just nip over here and do a bit of sorting out and tidying up before I get to my integrating, because otherwise you end up repeatedly writing this down every single time you rearrange the line. It's just a bit of a pain in the bum. So let's just sort it out first. X to the power half, multiply the bracket, we've got that. Do the multiplying there, and again, when you're integrating, it is far easier to work with fractions. So x to the power 4 times by x to the power half, add them together, 4.5 is 9 over 2. So that's where we're getting all those bits from. So that's the expression I've got to integrate. So now I've got that figured out. Let's go back to my integral. So there it is. I'm integrating that. Now we're going to physically do the integrating. And so that's where we've got this square brackets coming from. And if you want to just pause the video and just have a quick check, you're happy with where all of that has come from. And now I've got to evaluate it between the limits. So we're going to chuck in the 1. So that's my upper limit, substituted in here. And then chuck in the zeros. And now these things all turn out to be zeros. But again, I mentioned in the previous slide, in the mark scheme, you've got to be very, very clear that intention to substitute in both limits. So even though it's kind of blatantly obvious that this thing here is just going to become 0 when x is 0, you still need to make sure you're putting in, at the very least, a subtract 0 here. So you're showing the examiner, you put in the limits, 1 into there, 0 into here, and the intention to subtract. And then it's just a case of grab the calculator, and there we go. Moving on. So here we've got a bit more of a tricky question. So we've got to find possible values of k where our limits are expressed in terms of k. But what we've got here is we're told the value of our definite integral. So we're just kind of switching things around a little bit here. So that's what we're told. So the first step would be to do the integrating. So let's get that done. Notice as soon as I've done that, I've done my integrating. The square brackets have appeared. My limits are still there and equal to 2. So it's almost like, you know, you've got an equation. This line here is equal to 2. Let's do the equation by doing the first step, which is integrating. So clearly this thing is still equal to 2. Now let's sub in the limits and do the subtracting. So there it is. So I've put k into the first bracket. It's my upper limit. Here's my lower limit. So I've got k minus 2 cubed. So putting k minus 2 in place of the x there. So now what I've got is an expression all in terms of k, and hopefully this will turn out to be an equation that I can actually solve. Now, entirely up to you how you want to do the processing here. There's different ways of doing it. I'm going to leave nothing really much to do with that one at the moment, but this one I'm going to do some multiplying out of brackets. So k minus 2 all cubed. Entirely up to you what you want to do. Quick bit of binomial expansion if you know it. We've got the k minus 2 squared. So that's that bit. And then the bit on the end, which is that. And that thing still equals 2. Notice I've still got my square brackets because I've got the 2 bits here. And this is the bit where we've got to be super, super careful because we're doing a subtraction. So that bit is absolutely fine. It's the next bit. I've got to do minus all of this. So I've got minus k cubed. Notice the minus 6 at k squared has become a plus. Essentially this minus sign here has swapped all my signs. On the next bit, we've got to be really careful because we've got minus and minus. So that's going to make that into a plus. So I've got plus 4k squared. And this sign here still remains a minus. So again, it's just about picking your way very carefully through the minefield that there's all these different signs. And then the last bit, I've got minus all of this section here. So it's going to be minus 4k plus 8 equals 2. Okay, so really what we've got here is, you know, we've dealt with integration. This is just about you being careful and precise when it comes to manipulating more complex expressions and being very careful with all the signs and all the rest of it. So now let's have a look at what we can do to tidy up this whole thing here. So straight away we can see that the k cubes are going to disappear. We can see we've got some k squared. 4k squared there is going to cancel out against those ones. And that's going to leave us, let's just see if we can spot it. There we go. It's going to leave us with 6k squared. So do the cancelling. There we go. Let's have a look at the k terms. So I've got those bits are going to cancel, but I've still got some k's knocking around there. So those disappear, minus 28k. And then what else is going on? Well, I've got a plus 8 there, plus 8 there, plus 16. There we go, equals 32. And I've still got the equals 2 that's there. So this whole thing started out as an integrate, but it's now just become a quadratic in terms of k. How do I solve a quadratic? Clearly, get it equal to 0. And now do the basics of what I do with quadratics, which is either grab the calculator and just bang the numbers into your solve on your calculator. Or if you're a bit old school like me, you might want to do a bit of simplifying, a bit of factorising, and there you go, out pops the 2 possible values. And again, when I'm doing these kind of things, check, I've got 2 values of k, am I allowed 2 values of k? Yes, it says find possible values, plural. There's nothing to say that I can't have particular value, fractional values, or anything else like that. So there you go, job done. I've found the possible values of k, I've answered the question.